All right, good morning. So this is going to be our final exam review. So things you want to do. Actually, I've been asked, and I plan on making a final exam review in my math lab, so you guys get an idea. I think we are up. I think we have 10 questions. Okay, we have 10 questions. I can double check that. Hold on for a second here. Let's see here. How's this going? All right. Really? We're not gonna. Yeah, I think we're at 10 questions. All right. 10 questions, be 60 points total. Again, same way you've been taking quizzes. Okay, so let's see. We have basic integrals. All right, we have probably less than basic, like a more advanced, like probably a more difficult integral. Okay, so we'll just do an integral here. What I mean by basic integral, I mean something like we have 7x plus 2x squared, and this is all over like x to the 1/3 kind of a thing. So what you're going to have to do is say, well, this is 3/3, right? And divide by each one of these things. We're going to have a 7x to the 2/3 plus, and we have 2, and then this is 2 minus, or 6/3 minus 1, so it's going to be x to the 5/3, and it'll just ask you to integrate that. Okay. So that's what I mean by that. The less than basic ones is probably going to be U substitution problem. I gotta tell you that I think one of the more common integrals that this class uses is something like ln x over x. Okay, so we set u to be ln x, du to be 1 over x. Okay, and then you have a u and then a 1 over x dx. This piece here, that'll be our du. Okay, so it's just the integral of u du and let that go. So those are, yeah, those are U substitution type of problems. Okay, I know there's one where it kind of turns around. Okay, we're talking about like an x and then like an x minus 6 to the 4th power. You've got to go ahead and like set a u equal x minus 6 or x equals u plus 6 and then make a substitution for that. Okay, so those are like the three integrals that don't require fancy integration techniques. Okay, and I say that with a little bit of salt because some of the U substitutions can be a little difficult. Some these are definitely next level. These are definitely harder. Okay, so those are your basic integrals. There will definitely be integration by parts, probably more than one. Okay, and mostly what you're looking for an integration by parts is a polynomial times an exponential or a polynomial times a logarithmic. Okay, so anytime you see those and it's like there's not an obvious U substitution, you want to consider integration by parts. Okay, that's pretty much the only integration technique you guys have. Okay, there's others, but we don't cover them in this class. So if you have an x e to the x squared, okay, clearly that's going to be U substitution. You don't have to do integration by parts, but so this is still U substitution. But if you end up with something like an x e to the negative x, this is, this has to be integration by parts. Okay, so what you're looking for, again, polynomial times some kind of an exponential function, polynomial times a logarithmic function. Okay, that's a clue to say, oh, I will bet I'm going to be using integration by parts here. Okay, then we have volumes of revolution. So this is like what, 3-ish problems. Okay, 1 to 2 problems here. We have volumes of revolution. Yeah, now I'm not going to police anybody's notes. Okay, that's not, I'm not going to look at people's notes. I just want to, don't use a textbook. Make your notes. You have plenty of time to kind of set that up. So color code them if you want. That's fine. That's probably a good idea. Put important formulas, like you're going to be using integration by parts. You're going to be using a volume of revolution. So you're going to want pi f of x squared dx somewhere like on the front or near the front or the back of your notes so you have easy access to it. Okay, so get some kind of volume of revolution and how to kind of turn that around and get, that's going to happen. Big revolution there. I want it somewhere else. I want it around an axis. Okay, if you go on YouTube to look at these, just understand that a lot of these are used for the engineering calculus, and they don't just go around an axis. The basic ones do, but they could also go around the y-axis, or they can go crazy and like revolve it around some kind of a line. Those are really, really hard. I'm not going to ask you anything like this. We're not going to be doing something like that because you never had a chance to do something like that in homework. It requires a significantly different technique than what you're used to. Okay, we also have shells. We don't do shells. Okay, we just do what we would call washers. We don't even do washers because what a washer would be, you'd have some kind of a y equals square root of x thing, and then down to also by y equals x. Which would happen is you would revolve this thing around it, but there'd be a hole in it. That's what they mean by a washer, right? It's a hardware contraption that looks something like that. But we're not even doing that. So if you see washers, like, this is getting too hard. We're just doing cylinders. Okay, so we're not going to have to worry about that. Okay, we have L'Hopital's. Okay, and while I might pick an easier one for your final exam, I do tend to like the ones where you have to apply it more than once. Okay. Okay. Sometimes there might be an A and a B. So I'm not trying to do that just to make you work more and have more stuff to do. But what I'm doing for that is saying, well, can you do the standard one, and can you do one that's a little bit harder? So that way, if you get the standard one, like that's a 3-point kind of thing that you can get. And then if you screw up on this one, that's a 1 point. So for the whole problem, you'll end up with a +4. That's a C. So I don't want to penalize anybody. It's like, yes, I can do L'Hopital's, but not when it gets really complicated. Okay. So it's very possible I put an A and a B on some of these just to make sure it's like, well, can you show me that you can do the basic one? Can you show me you can do a hard one? And if you can't do the hard one, if you make an attempt at it, you still end up with a C on that problem. And that, like say, well, I'm looking for more than a C. I'm like, that's okay. But I don't want to just give you a 2 or a 1 and say the end of it. I'd rather get 3 plus 1, get a total of 4. So it's kind of to spare grade rather than just to make you suffer. All right, so that's volume of revolution, L'Hopital's. So remember that. The important thing about L'Hopital's, check for indeterminate form. Every time you're going to apply it. So you're going to need an infinity over an infinity or a 0 over a 0. Check to make sure that that's true. Then use L'Hopital's and show me that you're doing this. Okay, show me that you got an indeterminate form. Then apply L'Hopital's. All right, so that was one of the biggest mistakes people made on that quiz, is they just didn't show, like, we're just going to keep using L'Hopital's until I'm done. Like, you can't do that. You have to show me that it's an indeterminate form. Then you can go through and use it and do that. So just double check to make sure you're showing me, you're showing everybody else that this is why I'm using L'Hopital's. Okay, then we have improper integrals. Okay, and again, this one, the integral itself is relatively easy. Okay, so we're looking at something like a 1 over x squared, right, x to the negative 2 kind of a thing. And I'm going to be doing, like, integrate this from 2 off to infinity of x to the negative 2. Okay, so what I'm looking for is that you have a limit, right, as t goes to infinity, or pick your favorite letter, okay, of 2 to t, x to the negative 2 dx. Go ahead and do your thing. So let's limit t goes to infinity, right, of negative x to the negative 1 from 2 to t. Now we're going to say limit as t goes to infinity of 1 over t, negative minus negative 1 over 2. And actually apply the limit and do that. Okay, again, you got to tell me that you're using a limit. You got to write something like this down. Okay, you got to carry it through the problem. Again, if I looked at all the points that people lost on this one, this would have been the biggest problem, is that you just didn't write it down properly. Or actually, it's more than that, because sometimes I get like, well, in grammar, that would be a comma splice. So it's wrong, but you're still using the language. You're still getting it right. You're still using the right words. But some people just blew past it and didn't even do this. Okay, that's where you lost big points. You're still going to lose points if you don't use it properly. But we're talking about a 4 out of 6 or a 5 out of 6 versus like a 1 out of 6 for just doing the integral. Okay, so I'm not trying to like, this must be perfect. That would be nice, but I'm not going to take off a lot of points if it's not perfect. Like, I get the, how do you write this down? That's confusing and not everybody remembers all the time. I get that. Okay, but I want you to be able to say, oh, I've got to use some kind of a limit when this happens. Okay, because in a bigger problem, they don't do this to you, is that after you get done your improper integral and it goes off to like a 0 over 0, you can push it into a 0 over 0 issue. You get to go back to L'Hopital's to finish the problem. They don't pile it on like that. It's just good. Okay, but that's what could happen in another problem. If it was a bigger problem, or if you had to do this later on in a different class that was higher level. Okay, but I want you to understand like improper integral things. Okay, so let's see, we have maybe 3-ish problems, 4, 5, 6. Okay, so we're up to there, chapter 9. We're going to have, I'm probably going to pick a word problem for this one. Okay, when you have to do the partial derivatives. And again, since I'm giving you guys notes, I don't want to make the test too clumsy and too much there. So I'm usually going to rely on you guys to write down that table. Okay, so I won't provide that. You guys can provide this. Okay, then you had to figure out like, well, is fxx, fyy positive or negative? Are we getting all of these things? And one of the reasons I don't put a count on it is because I want you to write big enough to be able to see what you're doing. Okay, I can't tell you how many times in statistics when I used to let them use note cards, I get stuff like you have x bar minus mu divided by square root of sigma over n, and people would do that, and they would write it so tiny that I just get x bar minus mu, and I get 6 sigma over n. That's what that would turn into, and I feel bad about marking it wrong. It's like, you guys have the formula. I'm like, oh, I rewrote this and I got too small and I got 6, or I got 66 over n. Why didn't you? So use the room you have, write it in a way that you can read it, and we'll do that. Okay, but it'll be partial derivative, probably word problem where you have to go through and do all of that. Okay. We do not do the next thing, so I have to get rid of that problem. Okay, partial derivatives. Then I'll probably pick a double integral. And it'll probably be one, I only found one good one. I mean, this is kind of embarrassing. but I only found one good one where you have like a, you know, the function is bounded by like y equals x and or y equals 2x kind of a thing, and y equals square root of x. So you still have something like that, but it'll probably be a non-rectangular thing. Okay, or it could do an A and a B. One is with iterated integral, which is going to be fairly straightforward, or one that's got like some kind of a weird thing you've got to go ahead and integrate with the function. Okay, and just like the test, like I'll put them in the right order. I think that's what we did for the exam, is put them in the order for you to get them. But I'll try to find one so not too hard, but it's in there. Okay, so that's here's my parts. For the differential equations, just have to write your quiz. Let's see. I want a first order linear. That was 10.2. Okay. So that's another one post problem. It might be application problem. Okay, that is 10.4. I am partial to the mixing problems. Okay. But I might do some kind of a biology thing where you have a growth rate, you have some fish, we have a growth rate, you have the people that are responsible for managing this pond or this lake. We stock it every year because people do that for people to go fishing. Okay, that's one of the things that state parks do. And so you'd have to figure out that kind of a problem where you'd have like the dp over dt is proportional, right? The change is proportional to the population, but we're also going to be stocking it with a certain constant. We'd have to go through and do one of those. Okay, and I think let me just double count here. So what do we have? We have 2 or 3 here, 3 or 4, 5, maybe 6, 7, 8, 9. One of these will be 10. Yeah, that'll be perfect. Okay, so that's the mandatory part of the final. If you don't do these problems, you'll lose points. I will put in a couple of chapter 12 problems. Okay, again, I like Taylor series. Okay, but these are going to be, and I don't like this one. I did not like this problem. Okay, that is not a fun problem to do. Okay, but like how to integrate e to the x over x, like that's a good problem. Okay, because this is not a nice problem to do. Okay, there is no integration by parts. There's no fancy technique you're going to learn in engineering calculus. Nothing is going to help you solve this problem. You have to go through and say, well, what's the Taylor's? This is 1 over x times the Taylor series. It's 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4 over 4 factorial plus dot dot dot. This is going to be 1 over x plus 1 plus x over 2 plus x squared over 3 factorial plus x to the 3 over 4 factorial plus dot dot dot, and integrate that. Okay, and that's how you're going to get your answer for an integration that looks like this. And of course, we'll probably do something like, we'll probably go from like 1 to something, okay, or something. Okay, so you don't have to have a plus c in there. But that's the kind of problem I'm partial to, is to give you a Taylor series like this, say, integrate the Taylor series. Okay. I think there's a problem like this in your book because this is a very classic problem. Okay, but we'll probably do some geometric stuff, geometric series. All right, and we'll go with that. Okay, things that I did not mention but are still possible, do not trust me, because this could be on there. I just haven't written it yet, so I haven't decided. We have Simpson's rule. Okay, remember, this is if you have a bunch of dots, right, like that's your data. what we're going to do is we're going to try to make a function out of this. We're going to have the dots, and you're going to figure out what's the integral under here, okay? And it has to be even, okay? But I would write down the formula for Simpson's rule, maybe, okay? Well, definitely write it down, but there's a chance that Simpson's rule will be on a final, okay? Let's see, there is Euler's method. And it's not going to be crazy. I have one Euler's problem where, you know, this is what you get. I'm not going to do that one. That's going to be pretty tame, like you've done in the book. Okay. And I think we had one more numerical method. Oh, Newton's method. I know this is still chapter 12, but I could put a Newton's method problem on here. And again, I'm partial to the things like estimate. Using Newton's method, estimate like what's the cube root of 4, which you'd have x cubed minus 4 equals 0. This is what you would use, okay, in order to do that. Okay, so I haven't, like I said, I haven't written it yet, but write those down. They are definite possibilities for me to ask you. Okay, so if I can't find a good problem for one of these, I'll just say, oh, well, Euler's method is nice, or Simpson's method, or Simpson's rule is nice. So make sure you definitely write these down to do them. Although I also understand, like, these are mostly calculator exercises, and once you get it in the right format, like, there's no stopping you. You will get this correct. Okay, so it seems like it's mean because there's a lot of computation to it, but it's actually a nice problem because, like, use Newton's method too, or use Simpson's rule too. Like, you know what to do. There is no more doubt. And say use Simpson's rule. I always end up with this in statistics too. It's like, find a confidence interval. When a confidence interval is a very standard formula, you're supposed to go ahead and do it. And look at it and say, I'm going to use a method from a different chapter. That's what I'm going to do. Like, why did you do this? It said, here's the instructions, use them. So if it says use Simpson's rule, like, don't argue with it, just use Simpson's rule. You don't have to think about, like, what's going on. Just make sure you're doing this. Okay, same thing. Use Newton's method too. Like, you know, like, what do I do? That's over. Okay, we're using Newton's method. Everything will be provided, just like in the book. Like, I'll give you what the h is supposed to be. We'll say y of 1 is equal to 2. Like, everything you're going to need for Newton's method for Euler's method rather, that's all going to be there. The only one that's a little bit tricky is Newton's method. So it says estimate cube root of 4. You got to turn it into a function and deal with that. Okay, so we're not, you know, not trying to trick you with any of these. Use Simpson's rule too. There's it. There's no, you don't have to reshuffle anything. You don't have to change anything. It's just use Simpson's rule. Same thing, Euler's method. Use Euler's method too. Just use Euler's method. Okay, so that's 3 problems I have up my sleeve. I think I said, method. This is going to be extra credit. And let me just say about extra credit, because I don't want you to drill yourself and grind on chapter 12 stuff if you haven't made it. I don't want you to grind on chapter 12 stuff. It was like, this was confusing and I hated it and I could not do it. Like, I don't want you to have to spend like a lot of time and effort trying to do this. This is extra credit. So where a normal question is going to be 6 points, where I'm going to put 3 of these chapter 12 things on, each at 2 points, kind of a thing. So if you get them all, that's like an extra question. Okay. So if you're not comfortable with these, spend the time making sure, can I do, integration by parts? Can I do a double integral? Were these problems terrible? Can I set up a differential equation and solve a first order linear equation? Can I do that? Okay. More than maybe I should spend hours upon hours studying chapter 12 when I was not quite good at it. It's going to buy you an extra problem. Okay. So I might change my mind. It might be 3 points, but again, it's a 60-point quiz, or it's a 60-point test. If you're worried about this, like, you're in the wrong spot. Okay. Worry about all of the stuff that we talked about before. Okay. Make sure you can do, like, kind of do a Harlem Revolution. Maybe I should practice that more. Okay. How do you want to study for this thing? Well, It's comprehensive, which is good and bad. If people look at it comprehensive, that's going to be terrible. It isn't, because I'm going to ask you stuff from chapter 7. I'm going to ask you stuff from throughout the entire class. So where you may have said, I hate double integrals and I really have a hard time doing them. Like, that's one question. So that's not the end all and be all of the final exam. It's not going to be only the stuff you hated. Okay. It's going to be stuff from the entire class. And you might say, well, I like U substitution. I can do those. Like, there's going to be a question on U substitution. Okay. So it's not like drill down. I'm not going to like magically figure out the one thing that you hated and just make the entire quiz that. That's not a good final. Okay. Go through all the stuff that we did and make sure that we can do that. Okay. That's how I know, like, hey, did you pass Calc 2? Like, can you do integration by parts? Yes. Then you are good for, that's not the only question, but that's a big, that's a big point of being able to do Calc 2 is, can you do integration by parts? So yeah, there's obviously going to be integration by parts on here. So even when I do like the the first order linear kind of problem, you get that q of x on the other side. That might be an integration by parts problem. Okay, like you might have to multiply your integration factor, right? Might be e to the x. The q side might be x. So you might end up with like a y prime. We'll have e to the x here. Oh, just do y, sorry. Right, plus e to the x. No, this is right. Prime is equal to x, e to the x. And when we go ahead and do this, this was the derivative of e to the x times y. And then we have to integrate x e to the x. Oh, that's integration by parts. That came back and bit me. So this one's easy. This is just y e to the x. But this one, you're going to have to say, well, let u equal x, du equals dx, dv equals e to the x, v equals e to the x. So this is going to be x e to the x, right? Minus integral e to the x. And you got to fix this before you're done. So this is x e to the x minus e to the x. Now plus c equals y e to the x. Okay. So when you go ahead and now multiply by e to the negative x, okay, to get rid of this, you'll have y is equal to, and this will just be x minus 1 plus c e to the negative x. Okay, and there may or may not be a an initial condition like y of 0 equals 3. So we have 3 equals 0 minus 1 plus, when x is 0, e to the x is 1, c, we'll say, c is equal to 4. So you'll have your solution, y equals x minus 1 plus 4 e to the negative x. And that would be our solution. Okay. So you could have an integration by parts inserted into a first order linear equation rule. It's up here somewhere. Okay. So that's a possibility. Double integrals. I don't think they did any double integrals where you had to do integration by parts. So I'm not gonna bug you on that one. Okay. Improper integrals. I'm not gonna put integration by parts inside of this. You got too much to think about with making everything perfect. Okay, we're not doing that. But just like we did on the first quiz, volume revolution might be an integration by parts problem. Okay. So again, just like the problem where we had square root of x e to the negative x or something, when you squared it, it was x e to the negative 2x. This is integration by parts. We have to go through a deal with that. Okay. So be careful about that. All right. Again, not picking the worst problem you've ever seen. Okay, just trying to pick very standard problems, not trying to be that tricky, a little bit, but not that tricky. Okay, how you want to study for this thing? Again, I'll put a little thing up to my math lab, although they don't have the best problems sometimes. If you're worried about those, like, here's this 11-part monstrosity that they kind of guide you through. I'm like, nope, nope, not even close to getting something like that. I want you to be able to look at it and it's like, I know what to do with this problem. Okay. So you would want to go back and look at like your review problems. Okay. And you want to pretty much do like 1 to 2 from every section. And from about the middle. Okay. The middle problems. Don't do problem number 1 and say, okay, I got this. Like, do problem 5, right? Do problem 7, like 7, and then decide you got this. If, as you're working this stuff, you're like, oh, I did not get integration by parts. Excuse me. Put a little star next to it, highlight it in some other color, but give yourself a clue. Like, oh, when I go back and do my second pass, like, got to pay attention to these. Maybe you do 2 problems for these ones and you just do ones for the other ones. Okay, or maybe 3 problems, and then just if you have a lot of stars, maybe you do 3 problems for each of the stars, and then the next day, the next couple of days, you're going to do a second pass, double check that you can do these. If you ask to say, "Oh, show me a hint," you don't know how to do it. Do it until you don't need to show me a hint. Do it until you don't need to give me an example of. Okay. So you have to do it until you have to do these, try these until that you're good. Don't do it all in one day. Won't help. Well, a little bit, but you're better off spreading all of this stuff out. Okay, and that goes for all your other classes too. Like, you get your little final exam review. If they don't give you one, go back to your syllabus. We have course outcomes, course objectives. Technically, that's what your final exam should be. Okay, use this as a guide to decide which your final exam can be. If the teacher does not provide you like here's what we're going to cover. But if you don't have this, go back and take a look at these. These are the big questions that we're going to have. Make sure you can answer those. Okay. So I gave you a final exam review kind of a thing, tell you what kind of problems I'm going to ask you. Go back and test out, can I do this or not? And if you can't do it, then practice some. Okay. And if you have to go back and say, show me an example, like, don't sit there and say, well, I can't do it, so I guess that's the end. Like, practice it. But the next day, you got to come back and you got to do them again until you can say, can I do this without an example? Okay. I would do that. So let me give you one last thing here. All right. So in chapter 7, I think 7.2 was use substitutions. Okay. 7.1 was just integration. 7.6 was Simpson's rule. Don't spend a huge amount of time on this one. Okay, if you're not quite getting it, but it's close, like, call it good. Okay, you're not being graded on the reviews. Okay, but call that good. That was numerical integration. 8.1, that was integration by parts. Okay, 8.2, I think that was lines of revolution. 8.3 was improper. Again, you want to take like 1 or 2 problems from each of these sections. You don't want to like, I'm going to grind 7.2 until I can't study anymore. Like, that's not going to help you because there's more tests than there's time. Okay, so 1 to 2 problems. Again, pick something in the middle and do those. Okay. There was 12.3, which was L'Hopital's. Okay. Chapter 9, this is chapter 8, chapter 9. Oh, probably, yeah. Chapter 9 is you want to do the min-max ones. Okay, there's a couple of things where you get used to 3-dimensional coordinates. There's a couple where you just start taking partial derivatives and get used to that. But I'm probably going to ask you the min-max ones. So check these. Okay, I didn't mention differentials. We just had a quiz on that. Those are important. They're nice, but I've got a lot of other things to ask. So I think I want to not ask you that one for final exam. That was 9.4, I think. 9.5 was double integrals. I definitely ask you those. We had 10.1. Those were just separable. I could put a separable problem in there. I might, but those were just like another fancy way of asking you to take an integral. Okay, and I've already asked you several times to find integrals. So I think I leave 10.1 as not asking you specifically. But you have, I mean, I would maybe look. Okay, but don't dwell on it. 10.2, dwell on. Okay, this is first order linear equations. Make sure you can do one of those. Okay, 10.4. Okay, that was applications to modeling. Okay, I think what do we have? That's probably more than 10. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I got room for like one more in there. Okay, don't neglect Euler's method. That was 10.3. Get that down. Don't neglect Simpson's rule. Okay, again, not guaranteed I'm going to ask, but I just came up with 9 this time. And like, well, if I got to pick one more, those might be it. Okay, and then if you have time, if you felt like, okay, I'm solid, I want to do an extra credit one. I like Taylor series. I like Taylor series. You want to look at 12. Okay, I think there's just 3, 12.4 Taylor. Look at the other ones, 12.1, no, 12.2. Geometric. Geometrics was 12.2. All right, and Newton's method. All right, so those are the. Sorry, let me hold spot on that one for a while. But that's what your final exam is going to look like. I got to pick 10 questions out of this, and again, I'll try to come up with a review sheet for you guys too, so that you'll have something in my math lab to practice. Okay, so I think that should do it. I think that should about do it. Let me pause this thing. Okay, so I'll probably put on, because it's 10 questions, it's a little bit longer. Again, not all of them have to be like the worst problem you've ever seen, but I'm going to put in for 2 hours for this one, and that should be about right for 10 questions, right? So there we go.